When we think of space, we imagine stars and galaxies. What about the places where there's nothing? Join me as we explore the most massive void ever discovered. As the nothing between the something, outer space is actually classified differently. The region between planets that is bounded by the solar wind from the sun is known as interplanetary space. However, space is infinite. The region between solar systems that is only impacted by the black hole at the center of the galaxy and is outside the purview of any plasma bubbles is known as interstellar space. While that may seem overwhelming, intergalactic space, the area between galaxies, is an even more terrible category of nothingness. Approximately 90% of the cosmos is made up of this, and it's interesting to note how erratic and variable this empty space appears. This can be seen in phenomena such as the Botez void, also called the Great Nothing, which is a spherical region that is around 330 million light-years in diameter. The Botez void is expected to contain thousands of galaxies, yet only roughly 60 are found within this huge region. To put how empty that actually is into perspective, consider that in 1923, among other galaxies, humans discovered the Andromeda galaxy. However, until the 1960s or so, we would not have even known that there were other galaxies in the cosmos if the Milky Way galaxy had been located in the center of the Botez void. So why is there this space gap? We must grasp the fundamentals of the universe's nature in order to respond to that question. Galaxies gather into clusters in the cosmos, which functions like a sponge. For instance, the Milky Way is a component of the Virgo cluster. If you extend your zoom, you may observe that even clusters can merge to form superclusters, such as the Laniakea supercluster, which includes our Virgo cluster. Giant voids can be seen inside these superclusters, and if we zoom out even more, we can detect enormous gaps, largest of which is the Botez void between superclusters. But why do materials group together to create these enormous voids? The brevity and complexity of the explanation is that we believe it results from a variety of perturbations that occurred shortly after the Big Bang and spread over 13.8 billion years, creating regions with a far lower density of materials than those surrounding them. Despite being more intricate, the lengthy response is simpler to comprehend. Come back to the Big Bang, or better still, to 10 to the 32 seconds following it. Visible universe was, at this stage, incredibly little, incomprehensibly small. At this size, space-time underwent quantum fluctuations, which simply means that energy appeared and vanished at random. These quantum fluctuations typically have negligible effects because they are so tiny. These sporadic energy outbursts, however, interfere with everything when the observable world is so small, interacting with trapped light and basic matter. For over 380,000 years, the universe essentially played Pong, with photons due to these interactions, produced oscillations. Recombination finally took place, making stuff actual. The light that had been bouncing about was now free to expand out into the universe endlessly, just like everything else, which is how the universe generated its initial atoms. As a result, the universe is always expanding. In fact, cosmic microwave background, which is essentially the universe's fingerprint, is a picture of that very instant. It shows the microwave radiation that permeates all of space that may be observed. Have you noticed the erratic oscillations in this radiation? This is precisely how things seemed when they first began to grow, which explains why everything is now gathered together. It all started with random quantum fluctuations, and the universe's relentless expansion is what keeps the distance between everything growing. On the plus side, though, there's a huge gap in the market. Very neat, huh? Thanks for joining me on this journey into the mysteries of the universe. If you enjoyed this exploration, don't forget to subscribe to Philosophy World for more mind-expanding content. Until next time, keep questioning and keep exploring.